We know that shells are energy levels where electrons reside, and as the number of shell increases, that shell gets further from the nucleus. When I talked about atoms having unfilled shells in the periodic table, I didn't really talk much about the filled shells. So for example, if we look at lithium, atomic number 3, an atom has 3 electrons, there are 2 electrons in a filled shell. But I didn't talk about that filled shell because to chemists, the filled shell is rather uninteresting. And the reason it's uninteresting is because electrons in the filled shells do not engage in chemistry. It is electrons in the shells that are farthest from the nucleus that engage in chemistry, and that's what we care about. So how do we know what the valence shell is? So if we look at the periodic table, the period tells us the valence shell of the atoms that we care about. So for example, if we look at the first 3 periods where the atoms or the elements that we're going to care about in this course are, in the first period, the first shell is the valence shell. The second period, the second shell is the valence shell, and the first shell is filled. And in the third period, the third shell is the valence shell, and the second and first shells are filled. Now, not only do we care about which shell is the valence shell, but we also really care about how many electrons are in that valence shell, because those are the reactive electrons. And we can tell how many valence electrons a given atom has by looking at the group number that has a letter. So if we look at group 1A, every member of this group has 1 valence electron. And that's why hydrogen is in this group even though every other member is a metal. Family or group 2A have 2 valence electrons. 3A, 3 valence electrons, 4A, 4 valence electrons, etc., until we get to the filled shells. Now I want to point out an error on this figure 2.2, which is in your textbook. Not only does it show you the shells and the number of electrons in the valence shell, but it also gives you Z, or the atomic number, which for an atom is also equal to the number of electrons. And this slide says that the Z of helium is 10, it's actually 2. Now I also want to point out that helium is a member of family 8A, but unlike the rest of the members, it only has 2 valence electrons, not 8, because it only has 2 electrons. So be careful of that. Even though helium is in family 8A, it only has 2 valence electrons. So you're going to be required to determine the number of valence electrons that atoms have, and all you have to do is look at the family that element is in and look at the group number that has the letter to tell you how many valence electrons there are.